not too many corrosive or harmful chemicals to work with. The most, perhaps the most harmful one is toluene, and maybe the alcohols. The acids are quite dilute. Right? So obviously, you do not want to put your hand in whatever chemicals you have. All right, so we're going to do the titration. So we have obviously a burette, right? What should I put in the burette?
NaOH.
NaOH, right? So I have NaOH here, 0.1 molar. So especially when you're a short person like me, make sure you're careful with pouring solvents that are above your height. So it's important that you wear safety goggles and safety glasses. They're on the shelf there, if you can see it, right? And gloves are right next to it. Okay, so always wear gloves and safety glasses when you're working with chemicals. Notice I didn't put it all the way to the top. You can, but because the amount of free fatty acid I have today is really minimal, so you're actually not going to see very much or use very much. And so you would drain out some of it until you reach a level that, a starting level that you like, you know, whatever number you feel like doing. Okay, so always record the initial and final volumes of the NaOH you use. Okay, so that's the first thing. Next thing is to look at preparing your solution. Okay, so I have already made out the 1:1 isopropanol toluene with the phenolphthalein as my starting solvent. So actually, I'm going to weigh out the oil first. Okay, so if you the weighing thing is fortunately on the other side. Right, you guys can come over. Right, you can maybe some of you can go over here. Perhaps there's nothing much to show you except to weigh it out. Just to show you that we have two balances here, so it doesn't matter which one you use. So one thing with balance is you can tear, right? Tear the balance, right? So you put your whatever flask you have on there. It will register some weight, and there's a tear button on both balances. You can press to re-zero the mass, and then you would pour in, how many grams did I say? For titration. No.
91.
No. Titration. One to 10 grams, right, of the oil. Right, so roughly. So it doesn't really matter exactly, but you need to obviously record the exact weight for yourself. Okay, so that's the amount of oil. So I have 9.6. Okay, so we can go back. So 9.6. How many mils of the solvent? How many mils of solvent? 5, right? Have you all used this before?
No.
No? And so this is a rubber suction thing. So there's two pressing locations, right? You all see that? One on this end, one straight up. So you need to fill this, or you need to compress out all the air in this hole. So the way to do it is to press the one that goes up, and then press out all the rubber areas as well. All right? Okay, once you release it, it's gonna close. All right? And so then you need to pull up 5 mils of your titration, your solvent. And so the arrow tells you, right, goes up. So you should pull up. All right. So you need to look at the line where it says 5, right? 5 mils. If you have too much, then there's a release button to release out any excess, right? And then you add this to your oil. The easiest I find is just to take out this thing gently to get this drained down, right? Okay. Okay, so that's your starting mixture. You can see it's not quite colorless because your oil is obviously not colorless. Okay, so we're ready to do our titration. So even though I said that this solvent is to help you make it more miscible, right, with the oil and also the NaOH, you're still going to see some phase separation. And that's why we need to do this mixing to help you do the titration. All right, so you would register or mark down what is the initial NaOH level, and then you would titrate.
Is there an indicator in there already?
Yes. It actually doesn't use a lot of base to actually get it going. Right, so you notice it actually turns pink. I would wait a while because it's not too miscible. So if you want to speed up the stirring, you will find that eventually it loses its color. That's because the phenolphthalein is actually going into the oil phase to make it. So you can see, right, it suddenly disappears. All right, so obviously we need to add more base. Oops, I added too much. Anyway. All right, you get the idea of when the end point should be. All right, when it turns pink, this is really too pink for me. All right. This is way too pink, right? It should be the very first sign of pink that is stable, at least for, I would say, 30 minutes to a minute. I mean, 30 seconds to a minute. If you see it change color within 30 seconds to a minute, I would add like a drop more, or 1 or 2 drops more of NaOH. Right? It shouldn't be this pink, though. All right, you get the idea? And then you record the final volume of your NaOH to determine how many moles of base you need to neutralize, and then calculate your acid number. Okay, so fortunately for us, at least for vegetable oil or soybean oil, we don't have much base that needs to be used for neutralizing the free fatty acid. Okay, so the next step is to do the actual preparing for your reaction. So the volume of oil we're going to use is 100 mils, right, as I said. And so it's good, especially when you're dealing with different kinds of liquids, especially with some that are oily and some that are sort of alcohols, right, with the methanol, that you should not mix your measuring things, right? Oil is especially hard to get off, right? So if you use a cylinder for measuring oil, I would just use that for measuring oil and nothing else. Otherwise, you're going to get cross-contamination of your solvents and all that liquid. Okay, so I actually labeled it oil. Okay, so I'm going to measure out 100 mils of oil as my starting. So be careful of the, especially with this measuring cylinder, you see there's a scale that goes from top to bottom and bottom to top. Not sure why, but so make sure you figure out which way to go. Right, it's not 100 mils here, right? Obviously. Right, so I should look from the bottom up. Yes. And unfortunately, it does not show me 100. So 100 mils of oil will be into a flask. Okay, so 100 mils of oil into a flask. Try to make sure you don't have oil dripping down the sides, perhaps. Make sure it all lands in the center. Again, because oil is not very, you can see this vegetable is quite viscous, right? And that's one of the main reasons why you cannot just simply put vegetable oil in your diesel engine, because it's going to damage your engine. And so that's why we're breaking up that big molecule. Alright, so I would save this for oil. Okay, so the next step is to prepare your methanol, right? And the KOH. So to prepare the methanol and KOH, as I said, you need to do the calculation of the 300% mole percent excess of your methanol, and then 1 weight percent of your KOH plus whatever you need for neutralization. Okay, so the methanol here, I need 38 mils. So I have here one for methanol. Okay, so methanol. And you notice I didn't add it to the oil. And you'll see why later on. Okay, so that's methanol. The KOH is actually a solid. Right? You're probably used to the KOH being in solution, but it's actually, in its pure form, it's actually a solid. And so it's in this form of flakes. Right? Okay, so don't touch them, because they will become slimy with the moisture on your skin. And it's, right, as you know, bases cause very corrosive, so you don't want to touch it with corrosive. Okay, so I need to measure out 0.918 grams, right? Either you can come follow me, or I can just measure it.